Hello class, how are you doing today? We're ready to start week 3. You've been doing from my end a great job. I hope things are clicking for you. I hope you're liking some of the new features that we have with Revell and with your textbook, and that those are helping you to explore Java on your own, because it can be a little hard when you're online and doing things on your own. Let's take a look at our week 3 lesson and kind of talk a little bit about it. We have a lot going on this week, a lot of content. We're going to be looking at if statements and looping statements both in this week. Now, hopefully these are both concepts that are familiar to you from your 120 classes and maybe even from some other programming classes. But if they're not, you're going to have to spend some time with this week's material for sure. Realize that selection constructs, which are if constructs, and repetition or looping constructs are the backbone of any programming language. As you can see, I'm navigating through Blackboard, and I'm going to download the PowerPoint for Chapter 3. If you haven't looked at the PowerPoints yet from our book, I suggest that you do so. They do have some active links in them. However, to use those links, you do need to be playing the PowerPoint. So I may be moving around a little bit, and there's somebody emailing. Okay. I should turn those kinds of things off. I will learn that. All right, for Chapter 3, we're looking at selections, which are if statements. Why are if statements selections? Because I'm selecting which code to execute based on the result of my if statement. Now, here is a motivational slide for you, and they say if you assigned a negative value for the radius of a circle, the program would print an invalid result. If the radius is negative, you don't want to compute the area. So how can we keep things like that from happening? We can use selection statements or if statements to keep that from happening. An if statement or a condition that we use in an if statement and a loop results in a Boolean value. In this statement here, we've declared a Boolean variable named b, and we're going to determine its value by evaluating this conditional statement. And our conditional statement is 1 greater than 2? No, it's not, so the value of b is going to be set to false. Now we can interrogate b later to see if it had been true or false. Whenever we're working with conditional statements, we're going to build our condition based on relational operators. Over here on the left, you see the Java operator that you're going to use to build your conditions while using the Java programming language. First of all, we have the less than or equal to, greater than or equal to. Equal to, notice, is two equal signs together. If we just use one equal sign, we're assigning a value to something, and that can cause us some problems in our conditionals, so be careful with that. And the exclamation point equal sign is not equal to. Now they have some examples on this side of the slide. If we compared radius to see if it's less than 0, the value would hopefully be false, right? Our radius is 5, so that's going to give us false. If we compare radius to see if it's less than or equal 0, false, it's greater than. If radius is greater than 0, that's true. Is radius greater than or equal to 0? Yes, that's true. Is radius equal to 0? No. Is radius not equal to 0? Yes, it is 5. Okay, so we see that we can build our conditional expressions based on these relational operators, and we're going to have either a variable or a number or some sort of literal value to compare to. We could compare one variable to another, values to other values. It's wide open, whatever we want to do. Now, when you're looking at the PowerPoints for your textbook, this is a neat thing. Notice that in this slide, they're talking about the Simple Math Learning Tool program. Now, I can actually link to that by clicking on these active links, and that'll take me to the Armstrong website, because we just have some awesome things going here. Now you're going to see, if you run the animation on this, this is going to look just like the animation that you have available to you in Revell. So you have some different options here if getting to it through Revell is kind of a pain. I'm going to start this animation and take a look at this program. First of all, my class name is Addition Quiz. I'm starting out with my main, and I'm going to declare an integer named number 1, and I'm going to initialize that integer to a value based on the current system time. So I'm going to divide our current system time by 10 and get the remainder and do some things with that, and that's going to give me this sort of random number. Then number 2 is going to be also based on the system time. They're going to divide by 10 and then take the modulus of that. I ended up with 4 on both of those. That's fine. We're just stepping through this code. Now I'm going to create a scanner to input a value, and I'm going to prompt my user, what is number 1 plus number 2? So you see the output right here. This is what our user would be seeing based on this system.out.print statement. Now you may have seen earlier in your book println. Println will move the cursor to a new line, whereas print will not. So be careful of the differences of that, especially when you're working with hypergrade. Now I've prompted my user. In my next line of code, I'm going to read in the answer, and notice this nice utility online has given me a dialog box to enter my answer. The correct answer here would be 8. I'm going to enter 6 just because I'm like that. And now we see that that value for the answer was read in by me typing it. It was input into the variable named answer. As I continue on in the animation, I output a line, and this time I am outputting the line that says whatever number 1 was, and the plus sign, and whatever number 2 was, and an equal sign, and the answer, and the word is surrounded by spaces, and this math, number 1 plus number 2, if that's equal to the answer. So we're going to output right here our true or false value. So to summarize, running through this program, we did a print statement so that our cursor would stay on the same line so that we could input in that integer that was the answer supplied by the user. Then we utilized that answer supplied by the user along with the 2 variables that we created, and we compared the 2 of them in a conditional clause within our output print statement to generate the word either true or false. Phew, did a lot there, huh? Let's return to our presentation. So all we were doing in that one as far as conditionals go is outputting the value of that Boolean value. Now whenever we're looking at if statements, we can have single selection or one-way if statements. This is the kind of if statements where I say if the radius is greater than or equal to 0, I'm going to do something. Notice on our false path in this flowchart, we bypass our code and we do not perform any action. In this example, if the radius is greater than or equal to 0, I'm going to set the area equal to the correct formula, and I'm going to output that information to my user. That's a one-way if. In the 120 class, it's referred to as a single selection if. Here's some notes for you in the presentation, some if statement demonstrations for you to look at. Now here's a two-way or a dual selection if statement. This is an if statement with an else clause. If my if statement is true, I will execute statements based on the true condition. If my statement is false, I will execute statements on the false. Let's take a look at our Java syntax for an if statement. First of all, we start out with the keyword if. Case matters, so it's going to be a lowercase if statement. Then within parentheses, we have our Boolean expression. That could be a variable, that could be a comparison, some sort of conditional operator. Whatever we have, it has to be enclosed within parentheses. Then we have an opening curly brace to indicate the beginning of all the statements to execute if our if statement evaluates to true. At the end of those statements, we'll close our curly brace. Then we have our else clause indicating this is the beginning of the block of code that should execute if our if statement is false. We have our opening curly brace, all of the statements, and our closing curly brace. So you see it here in a flowchart mode and in the code. So we don't need to complicate this. It's as simple as can be. What I'm going to execute if my if statement is true, and what I'm going to execute if my if statement is false. Here's an example. If the radius is greater than or equal to 0, I'm going to calculate my radius. I'm going to output the information. Otherwise, if the radius was not greater than or equal to 0, I'm going to output a message that I have received negative input. Now, I can also support multiple alternative if statements. Notice the difference between these two blocks of code. First of all, I have if this, print that, else if this, print that, else if this, print that, else if this, on and on and on. This is equivalent. I say if this, do this, else if this, do this. Now, notice that it condenses our code, makes it a little bit easier to read, but it is also a better performance feature for the system because we don't have as many branch statements within our code that's generated behind the scenes to execute on the processor. So with multiple alternatives, we want to indicate and use the else if syntax. Take a look at this. Notice that I can say if I have all of my else if conditions, and then at the end I have my final else if none of these conditions are matched. Again, I could use curly braces in all of these to execute multiple lines of code. This code is indicating that if I only have one line of code to execute after each of my condition, I do not need to enclose it in curly braces. And here's a flowchart of that. And of course, if you would like, please get on this PowerPoint and do this animation. I'm going to jump right through it. There's a bunch of wonderful information in the presentation for you. Notice this is a common error, adding the semicolon at the end of an if statement. That will cause you all sorts of problems, and you'll see all sorts of terrible, weird errors, and you won't know what's going on, because it is a logic error. It just makes things not work properly. Please be careful of that. In this situation, they're showing you some more tips, some cautions. Please take a look at those. You have some problems and some case studies that you can look at through all of the different information. Now, when we're building our conditional clauses, sometimes just comparing one value to another is not enough. Sometimes we need a compound expression. We need to be adding some additional junctions in this. Now, this is an important point for you. Let's see if I can bring this up. I'll do it not the best way. An important thing for you to be thinking of. I hope this volume doesn't blast you. Please plan accordingly.
Conjunction, junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction, junction, how's that function?
I got 3 favorite cards that get most of my job done.
Conjunction, junction, what's their function?
I got and, but, and, or. They'll get you pretty far. And that's an additive, like this and that. But that's sort of the opposite. Not this, but that. And then there's or. O-R. When you have a choice like this or that. And, but, and, or get you pretty far.
Conjunction, junction, what's your function?
Hooking up 2 boxcars and making them run right.
Okay, conjunction function, it's awesome. That's what we're doing here, talking about how we can hook up our different conditionals. And I want you to really think about that song. We do have those same functions, and, or, and not. This is our but, basically, conjunction. And we express those when we're building logical conditions using the exclamation point as the not operator, double ampersands is our AND operator, and the double pipe character, which is the shift backslash right above your enter key, is our OR operator. Now we also have one other condition, and that's an exclusive OR. So as we're looking at OR, we say if A is true or B is true, where A and B are both conditional statements or Boolean values. If A is true or B is true, this statement is true. If we're using the caret, we're saying basically if A is true or B is true, we're okay, but not if A is true and B is true. We'll take one of them being true, but not the other. They're exclusive. I'll only take one of the two being true. So a very unusual condition. Now, here are some examples of different compound conditions. Again, I'm going to let you look through all of those. As you're beginning programming, a truth table is an important idea and concept. In the truth table, we're going to write down our different conditions or clauses, and in this case we're going to take them and evaluate whether the whole condition is true or false. So in this first one, we're saying part 1 is if the age is less than or equal to 18. Well, our age is 24, so that's false. Now the second part of our conditional is the weight less than 140. Their weight is equal to 140, so again that one comes out false. So we end up with part 1 false, part 2 false of our compound condition. So when we AND those together, our compound condition ends up being false. In this case, we have condition 1 becoming true. Our age is greater than 18. Condition 2 is the weight greater than 140, false again because our weight is equal to 140. So we have a true and a false. Now our multiple condition here, our operator is the AND. So since we have a true and a false, we're going to end up with a false value. As compared to this next one, where part 1 is true, age is greater than 18, we've modified this conditional a little bit, so now it is true because we've added in the weight being greater than or equal. So now we end up with true and true, so our end result is true. To think about these things, again, some more truth tables for your consideration. Please take a look at those and take a look at the examples. I'll be doing another video to talk about chapter 5 and looping so that we can talk about some of the general information available in that. Now the last conditional type statement that we need to be aware of is the switch case statement. And in the switch case statement, we're evaluating usually an integer value. And in Java, we're going to evaluate that by using the keyword switch. Within parentheses, we're going to name the variable that we want to evaluate. We're going to begin our switch statement with opening curly brackets and close our statement with closing. Then we're going to specify each case. So for the case that this status variable equals 0, I want to do this and then break out of the case statement. In the case that the status variable equals 1, I'm going to do something else, break out, etc. So notice no matter what we do, we have to break out of the statement. In the end, we can specify a default statement if none of our other case values are evaluated as true. It will execute our default statement. Please take a look at that. The switch statement is very powerful, and it is also a very efficient way of handling evaluation on a single integer. It is a preferred method. So as you're looking through, you'll see again a lot more examples in our book and animations in the PowerPoint explaining how that works to you. For Revel for this chapter, I have assigned just about like 15 points or something of examples. As you look at Revel, you'll notice that I've added a lot of things. I'm kind of jumping through here. A lot of things that will give you an opportunity to finish some of the projects using the Revel facility. I've put all of those at Christmas time or beyond, December 25th and beyond. outside of our semester range. So any of the assignments you see in Revell that are outside of our semester range are simply out there for you to practice. They'll have no impact on your grade. Now we have one other type of operator that we need to discuss whenever we're looking at Java, and this one is a little bit different. Here we're saying that we can, this is called, let me back up here, this is called a ternary operator. So what I'm going to do is evaluate an expression, and then I'm going to use the question mark as a special character, a required character, and after the question mark I'm going to say what I want to happen if that evaluates to true, and then after the colon, what I want to happen if the Boolean expression evaluated to false. So this is a little bit different of a way of doing things. In this example, I say that if the number mod 2 is not equal to 0, it's a even number. Oh, I'm sorry, if it is equal to 0, sorry, it's evenly divisible by 2, so it's an even number, otherwise it's odd. Now I can accomplish that same code using a ternary operator by saying num mod 2 equals 0. That's my Boolean expression. Is that true or not? If that's true, I'm going to output after the question mark, num is even, then I have the colon to indicate my false path. If that evaluates to false, I'm going to print out num is odd. The ternary operator is definitely odd, and it will give you some fits, but it's very, very powerful. So please kind of familiarize yourself with its use. When we're evaluating conditional expressions, we have an operator precedence, just like when we're working with math problems. It can be highly, highly complicated when we're working with Java, so it is important to use parentheses and try and clarify as much as possible so that the people following along behind you do not have to figure out some sort of giant operator precedence nightmare. So let's remember that we want to keep it simple. We don't want to complicate things using all sorts of major upsets. We're going to give you all sorts of examples again about evaluating order. Finally, debugging. When we're working on a program, we often run into bugs. We want to utilize the debugger utility that gives us abilities to resolve those bugs. Some things that debuggers allow us to do are execute our code a statement at a time, trace into or step over a method so that we can see what we have before and after we execute it, set breakpoints so that we can stop at specific spots in our code and evaluate what we have going on, look at the value of variables, display those variables, display what's going on in the system. We can sometimes even modify variable data values and continue executing our program to determine what happens with those new values entered. When you're looking at NetBeans, be sure to look at this supplement, how to do some debugging when you're using NetBeans, and the same with Eclipse. Lots and lots of power there. This is not something that I want you to miss out on. I don't currently have videos available for this, and we'll see what we can do about that, but those videos are definitely available from your textbook manufacturer, which is wonderful. I'm going to stop this video. Again, we're going to continue on with Chapter 5. We do have a lot of information to cover this week, and I hope you're enjoying the class so far. I'm really enjoying working with all of you. See you in a